Hello everyone. In today's problem, we want to see if we can find intervals that this function f of x is either positive or negative in it. So let's look at a generic function on the xy plane. So if this is x-axis and this is y-axis, a general function may look like this. Therefore, we can see that if this point is x naught, for x values that are greater than x naught, this function is greater than 0, which is positive, and for x's that are smaller than x naught, this function is negative. Now, this doesn't happen to all functions. There might be a function like this that touches the x-axis at x1, but it changes its curvature and remains negative. Same for this function that can touch the x-axis at x2, but remain positive. So just by looking at these plots or these functions that we are showing on the x1, xy plane, we can see that if we find the roots of the function, or where the function becomes 0, then we may be able to say something about the intervals that it is positive or negative. For example, this function, if it is 0 at x naught, after x naught it will be positive, and before we reach x naught it will be negative. Let's look at our function f of x and see if we can find the roots of that. Now, this function is the product of three separate expressions. These actually four. These four parentheses, and we know that if we find the polarity of each of these expressions in the parentheses, then if we multiply the polarities, we can find during which interval this f of x is positive or negative. So as the first step, we can find the roots of the function f of x. And this is a general way to solve the problems like this. It can be a more complicated function, or it can be a very simple function. The first step that you take is to find the roots. So if f of x is 0, then either 2x is 0, so x can be 0, or x minus 1 can be 0, so x can be 1, or x plus 2 can be 0, so x can be minus 2, or minus x plus 3 can be 0, so x can be 3. Now we can make a table like this, and as the first row of the table, we just write the roots that we found in increasing order. So we will have minus 2, 0, 1, and 3. And then for each row, we will put each of those expressions. So row 1 is 2x, row 2 is x minus 1, row 3 is x plus 2, and row 4 is minus x plus 3. And the last row will be f of x, which is the product of these. Now, if I make have a dotted line under all of these roots that we found, we know that 2x is 0 at 0, x minus 1 is 0 at 1, x plus 2 is 0 at minus 2, and x minus 3 is 0 at 3. So f of x itself is 0 at all of these 4 points. Now, 2x is negative before it's 0, and in order to find that, we can just replace x with a number less than 0 and a number greater than 0. So if we replace x with minus 1, we will have minus 2, which is negative, and if we replace x with plus 1, we will have 2, which is positive. So this function 2x is negative, negative, positive, positive, positive. Same thing for x minus 1. It is smaller than 0 for x values that are smaller than 1, so it will be negative, 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 positive, positive, and same for x plus 2, it will be negative, positive, 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 positive. But for minus x plus 3, because the sign of x is negative, it's going to be positive for values that are smaller than 3. So for, let's say, 0, if x is 0, minus x plus 3 will be positive. So it's positive, 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 negative. Now, because f of x is the multiplication of these four expressions, then we can multiply the signs and then find the sign of f of x. So f of x is 0 at the roots of each of those four expressions. So this point, this point, this point, this point. And then for x values smaller than minus 2, it will be negative times negative, which is positive, times negative, which is negative, times positive, which is negative. So it will be negative here. For x values between 2 and 0, it will be negative times negative, which is positive. For the interval between 0 and 1, it's negative. 1 to 3, it's positive. And 3 to infinity is negative. So this way we can find the polarity of the function f of x by finding the polarity of the subfunctions that comprise f of x and multiplying the polarity of those. So this is a general method for finding polarity of any expression, complex or simple. And in some future more advanced problems, we will also discuss if the function f of x is ascending or descending, or if it is increasing or decreasing. But for now, we can just stop here till we get to that more advanced problem.